Hello and welcome to Office Hours by Bit Gardner. My name is John Kowalski. I'm part of the marketing team here and I'd like to welcome you. Today's presentation is on color measurement tools and uses. If you're unfamiliar with our Office Hours format, it's basically a shortened presentation, usually 20-25 minutes, followed by your questions and discussion. If you do have questions about the presentation, about a challenge you're facing in one of your facilities, please log it in the chat box. It should be in the bottom right-hand corner of your screen, and we'll get to it. Also, we are recording this. So immediately following the presentation, you'll receive an automated email that will contain a link to this recording, and feel free to share it with colleagues, listen to it later, whatever you like. Our presenter today is our application specialist, Mr. Noah Morgan. Noah, it's all yours, sir. Take it away.
All right, thank you, John, for the introduction. So today we're going to be talking about color measurement tools and their uses. So we're going to start out with the Spectra 2 guide. This is one of our new handheld color instruments. It comes in two different geometries, a D8 with spin and specs, spin being specular included and specs being specular excluded. It also comes in the 45-0 measurement areas to measure as we see color. For the color measurement, the illuminated measurement area is 12 millimeters with an 8 millimeter measurement area with that sample port. And it also measures 60-degree gloss in a sample area of 10 millimeters and a measurement area of 5 millimeters. Now with this instrument, it's highly repeatable. So it's repeatable with a delta of 0.01. And with this instrument, you could also use digital standards, which is important when you have, say, a supplier, instead of sending out several different panels for standards to different plants, they can just send a file with the standard in it. That way, everyone will be using exactly the same standard and there's no variation between the panels. And this can be important because sometimes a panel might be slightly different depending on where you're taking the measurement from. And when you go and have a sample that you're measuring to in one plant and it's on the high end of a tolerance, and then the sample in another plant's on the low end of tolerance, because those original panel standards were slightly different, they can end up being completely different colors when those two samples come together. So let's talk a little bit about how gloss is perceived. So in this image here, we have a light source coming in from an angle, and then it's reflected off of a glossy surface back towards an observer. And so we can see here that there's a little plus sign, and in this plus sign, it's kind of giving you a reference for if that glossy surface is so glossy that when you're going to look at the visual for the illuminant, that illuminant's going to appear very clear. And so that's what this is supposed to represent here. And it's important because the incident light is directly reflected onto the surface, and then that incident light directly equals the angle of reflection. So that's how gloss is usually perceived with our eyes. So light shines onto a surface and then reflects back. And if it's very glossy, we're going to see most of that incident light reflected back towards our eyes. Now we have a matte surface, and with the matte surface, you could think of it like a surface that has a lot of micro texture to it. And so you can see these little rays are being bounced and reflected in different angles. Even though light's coming from the same angle as it was before with the glossy surface, we can only see a little bit of it coming back towards our eye at that exact angle that the light's being casted on, whereas we're missing all this other light that's being reflected because of this microsurface. And so when you look over at this image on the right, the plus is a lot blurrier because that surface is matte, meaning there's these micro textures that are messing with the way that light's being reflected back towards our eyes. So why is this important? It's important because gloss has an influence on the way we perceive color. So you see these two panels, one's black and one's red. And with the black sample, the upper one is a glossy surface and the lower one is a matte surface. And it's important because these two materials are exactly the same, with the same color and pigmentation, but that gloss plays an effect into how we're going to perceive it. And same with the red. The top is a glossy surface, whereas the bottom is a matte surface. Even though they're the same pigment, that gloss is going to affect the way we see it. So how is color perceived? Despite the gloss is going to come in from the angle from the illuminant and reflect back, and we're going to observe it from that opposite angle. That's how you view gloss, but when we're trying to do color, we have to look at it from right above it. So that light's going to come in from an angle off the side and reflect the gloss out towards the opposite angle. But because we want to look at it from the side, we're avoiding that direct light being cast back into our eyes. And that's important because you can think of it when you're reading a magazine, you don't want to read it at an angle if you have a light source around you, because that light source is going to reflect back into your eyes. You won't be able to see as well. So you want to hold it flat to where you're avoiding that light angle so you can actually read the words. And same on a matte surface here. You want to avoid that direct light coming back into your eyes. So you want to observe it from a 0-degree angle. So that light's coming in from a 45-degree angle, and you're going to view it from a 0-degree angle. Now it can also change where the light's coming from above, and you're viewing it from a 45-degree angle. It's called a 0-45 instead of a 45-0, but both are the same thing essentially. So it's important with these instruments that I've referenced before, the Spectra 2 guide, that instrument with the 45-0 geometry inside of it, it works how we perceive color with our own eyes. So you can see here, it works internally with the light source coming from that 45-degree angle, coming from all sides, so circumferential. And then we view it at 0 degrees, and that's where the sensor is located inside the instrument. And so we avoid that direct gloss showing onto the sensor, which reflects exactly how our eyes see. So with this instrument, a difference in gloss and structure is going to equal a color difference for us. And that's why it's said 45-0 as we see it, because it's going to determine the color exactly how we'll perceive it with our eyes. And so typical applications with this is a comparison to a defined standard. So say we have a sample and we want to compare it to what our standard is. We're going to use this 45-0 because it's going to give us the end result of that exact value that we're going to be able to perceive. It's also used for batch-to-batch control and harmonization of various materials and structures. And it says, again, difference in gloss and structure is going to equal to a color difference. And this 45-0 geometry is going to be the right geometry to use in order to figure out what that color difference is. Now, I also spoke about the D8 geometry with the spin and specks. And so this is the specular included. And you can see it's very different from how the 45-0 is, where the light's coming from all angles. This is a sphere essentially with a white coating inside, and the light's going to come in from the side, and it's going to get reflected throughout the entire sphere. And then what that creates is diffuse light being cast onto the sample instead of direct light. And we want this because it's not going to take into the account of the gloss and structure. It's just going to take into account of the actual color on there. You can see typical applications for this is color matching, so just pigmentation without taking into account the matte and the gloss. And it's also the color strength development. Weathering studies are also typically used with this method because you can see how erosion will affect a panel or a color panel. And then on the contrary, we have the specular excluded. And what this incorporates is a gloss trap. And so what that does, it's able to almost give you It'll correlate to the 45-0 a little bit, but not 100% because of the different methods at which the light's being cast onto the sample. Once again, with these, just like the spin, it's being casted in from the side and reflecting throughout the entire circle to give you a diffused light on the actual sample. And then that gloss is being reflected back up into the gloss trap to give you a little bit of a gloss angle for that. And that's how it'll correlate to the 45-0. And you can see in this one, differences in gloss and structure are also equal to color differences. Like I said before, it has good correlation with 45-0 on high gloss surfaces, but as you lower that gloss level and the sample becomes more matte, your correlation to the 45-0 is going to diminish slightly. So here you have all three of those methods compared together. So you have the 45-0 geometry compared to the D8 specs and the D8 spin. And you can see here that the 45-0 is slightly the same as the D8 specs, with a few differences here with the L value and the A value, whereas the D8 spin method is completely different. So it's you could see, because this one only uses that color instead of taking into account the structure and the gloss levels, it's going to be completely different the way we see it. And you can see based off a black glossy surface here, it's a little bit the same, but when the black matte surface is introduced, the D8 specs is varying from the 45-0, like I explained earlier. Over here, we have the comparison again, but this is back with those original samples I showed you with the red glossy and the red matte. And you can see here with the 45-0 geometry, it correlates somewhat to the D8 specs with slight differences as you get more matte. And over here with the D8 spin geometry, it's almost completely different than the 45-0 and D8. So this is important because in some plants, if you're comparing samples with another plant and they're using a different geometry with their instruments, you're going to get complete different results. And this is one thing you could look at to make sure you're both using the same exact geometry. All right, so moving on, we're going to talk about how we can describe black and brownish neutral colors, and bluish. And it's hard to see in this presentation here, but if you look on the right side, these black panels here appear more brownish, they have more undertone of brown, whereas these panels on the right side appear more bluish. They have a bluish undertone. So the trend in most industries now are moving towards these very deep black colors. They're visually appealing to consumers, and so that's why the industry is moving a little bit there. So the issue comes up to how can we give values to these colors, because black is considered the absence of all visible light and color. It's not really a color. So there's talk of, should we use LAB values to describe the black color? And so this is an example of a spectral profile of a black color, one of those deep blacks. And you can see it's almost completely flat all the way across the board, meaning that there's no color that's being picked up there because it's so deep black. So the idea is, how can we distinguish between these undertone colors? And so to do that, we introduced new indices that include MY, MC, and DM to describe these deep black colors. And so we have the MY, it is the hue independent black value. So it's the black value basically describing how dark that black is. And then we have MC, which is the color dependent black value. So that's giving you what that undertone is on that black value. And then you have the undertone DM, which is the absolute contribution of the hue. So that's the absolute color that's in that undertone. And all these get combined and give you some values to describe these deep black colors. And you see, you get the DM, it's the color dependent black value minus the hue independent black value. and that'll give you the undertone black value. All right, so once we figured that out, we came into another issue where the electrical noise that's inside the instrument is starting to affect the measurement. And so you can see in this graph here that this line is getting so low, so we were able to distinguish very accurately what this black color is. But at a certain point, we come into the problem where the electrical noise caused by an instrument is creating a problem, and it's giving us these varying results. And this is something that all electrical components have when you have a machine running. There's always going to be this small amount of electrical noise, and you can see it's so small. It's not big and substantial. So with normal colors, it doesn't make a difference. But when you're trying to get these very accurate deep blacks, you're going to see a little bit of variation there. So to combat that, we created the Spectra 2 Guide Pro, which is able to get into these very deep black colors and get accurate results with them. And we were able to do that by reducing the noise by using the highest precision electronics and optical components. We also adapted our production process slightly so that we're able to get down and make sure this noise goes away. And we're also able to amplify the LEDs, so we made them more powerful with more energy. And so they had a higher light intensity on top of that surface, and also gave it an extended illumination time, so it had more time to grab the data from that deep black color. And you can see this is from testing that was done with the Spectra 2 Guide Pro. This was a deep black sample, so at an MY value of 393, which is very deep black, and it almost barely reflects light. And so we were able to test it 50 times in the same spot. And you can see this graph looks like it's scattered all over the place. But when you look at the values over on the left side, you can see how small we're actually getting down to the measurement. And after these 50 measurements, we only had a deviation of 0.0002, which is very low. So we were working with a company called Orion at the time that develops these deep black pigments. And they gave us the go-ahead and said this was acceptable for their testing. And once again, this is the Spectra 2 Guide Pro with the jetness mode. So we adapted our production processes by using the highest precision electronics and optical components. We gave it a special calibration routine, the temperature stability test on a dark gray instead of a white tile. To improve that black detection. And then we improved the jetness mode by giving the LEDs more powerful with a higher energy. And we used that extended illumination time, so I had more time to calculate what that color is. And you can see down below, this is Orion Engineered Carbons. So they're the company that actually helped create this instrument here. So moving on from that, we have effect coatings, which is another different topic on how to measure color. You can see a lot of the cars today in the automotive industry, they use metallic coatings, pearlescent coatings, special sparkle effects. And the issue with this is you can't measure it with a conventional 45-0 or D8 geometry, because you have these light dark flops. And that basically is when you have curvature on these cars. You can see on this silver car here with the gray door, those contours, the way that light's casting onto that at these certain angles, it's going to change the way we see it as we change our viewing angle. And then same with pearlescent coatings that you have on these fancy sports cars these days. That's going to change complete different colors as you move around the car. So how are we going to measure and make sure that all these panels are going to match when they're put together when you have these pearlescent coatings on it that change as you go around the vehicle or change your viewing angle. And then down below, we also have those special glitter effects where it'll sparkle. And that's important too, because you need to measure that sparkle area and the size of the sparkle and the way the sparkle is laying on the finished product. So how do we measure that? We have an instrument called the BYK-maci, and it uses multi-angle measurement geometry. So you can see here, if you were to test on a solid green color, like in this example, all these lines for the different angles. So we have 15 degrees, 25 degrees, 45 degrees, 75 degrees, and 110 degrees. And when you measure all these angles, you're getting pretty much the same result. It varies slightly, but you can essentially say that they're pretty much all the same. But as you change to a metallic color, like this metallic green, you can see now that all these angles, you see a completely different color. It might get lighter or it might get darker. It could change hues slightly. And so that's an issue when you're trying to measure things. You need to make sure that everything's the same under each angle. And so this is another example with the silver. Silver is one of the hardest colors because it can change so drastically depending on that hue of silver. So we can see here, unlike the green where it was a little bit closer together, this one is completely different. So you can see at 110, it's very dark. But if you're up here at 15 degrees and you're bringing it from this 15-degree angle, it's very light. And so you can see that in the contours of that car up in the top right corner. So this is the BYK-maci with multi-angle color and flake characterization. Has an illumination at 45 degrees and then detection angles at 6 different angles. So you have -15 for the pearlescent colors, 15 degrees, 25 degrees, 45 degrees, 75 degrees, and 110. You also have the sparkle characterization I spoke of before. And so with the sparkle characterization, you have 3 degrees there, 15 degrees, 75, and 45. And it's important to know those angles because sparkle at 75 degrees will show issues in your process with the way the sparkle is laying on that coating. And so if you detect an issue with different sparkle numbers and at 75 degrees, you're gonna know that you need to change your process because something's going on in the process that's causing this to be different from the other samples. And then at 15 degrees, if you see a difference there, it'll show you an issue with your formulation of your paint. So that's important to know, and this device would help you figure out what's going on there, help your process. Like we spoke earlier, camera detection's at 0 degrees for the sparkle characterization. That's just so we can see where the sparkle is. It's how we're going to view it with our eyes. And then we also have the graininess characterization. So it uses diffused illumination, and that'll detect the grain in the pigment. All right, so that about concludes it. Are there any questions?
All right. I'm sure there are questions. Thanks, Noah. Great stuff. Lots of good information you shared with us today. Thank you. If anyone out there, has questions, please log them in the chat box, and we'll get to them in order. I have a few already here. First off, and I believe this is referring to the Spectro 2 guide that you first talked about. Apertures, are they interchangeable? What are the sizes that we have available?
So for the Spectro 2 guide, they're not interchangeable,
Okay.
but they do come in. Let's see, we can bring it up. So it's a one size, and that one size measures You have to have a sample that's 12 millimeters to fit that port, but the actual color measurement's 8 millimeters. So it only uses 8 millimeters out of that 12. And for the gloss, you need a sample that's at least 10 millimeters wide, and it's going to measure only 5 millimeters of that sample.
Okay, great, thank you. Next question here. Can you clarify digital standards and how they improve color harmony?
Yes. So say a supplier, and they're going to send out, let's say, 5 standard panels to
Okay.
different plants. And these panels, they could vary slightly. It's sometimes it's very small. They vary slightly depending on where you're taking the measurement or just how they were made. And so if you have all 3 of these plants and they're using this standard panel, they might all be slightly different now. And this could create an issue because, say, one of the panels has a slightly higher L value than another panel at another plant. And if that plant were to take samples and match them to the standard, and say one of the samples they had was at the high end of the tolerance for the L value, and another plant has a sample that has has an L value that's at the very low end of the spectrum. So say those samples both ended up coming together in the field, there could be a very big difference that would be between those 2 panels because that standard was slightly off. And with these digital standards, it's just a file that you can send and import to your instruments, and it only takes 5 minutes, and everybody has the same exact spectral profile and LAB values that they're using to measure these standards. So it makes everything a lot easier in the long run when you have all the standards exactly the same.
Okay. Great, thank you. And for the folks out there listening, we do have a handful of business line managers, regional sales managers, and inside sales managers on the line also. And one of them just pinged me here. Apparently, the Spectre 2 guide that you see on your screen, the Sphere version now has a 4 millimeter option. That I guess just came out. So keep that in mind. And anybody from the field too, feel free to unmute yourself and chime in, and just looking for a good discussion here. So thanks for that information on the color harmony, Noah. Next, kind of a follow-up to that one. What would you recommend for harmony, the 45-0 or the Sphere, which is specular included?
For color harmony, I would recommend the 45-0 just because that would give you the best representation of what you're visually going to see in the end. So
Okay.
because of that circumferential illumination, that's going to give and it uses that direct light as well. That's going to give you your best representation of what you're going to see visually when the parts come together.
Okay, nice. And you on the BIC-mac, you talked about the sparkle index and the sparkle angles of those. Can you kind of recap that again? Out of those angles, what are the most important?
Let me pull that up real quick.
Yeah.
So the most important angles are 75 and 15 degrees, because at 75 degrees, you can see here on the screen,
Yeah.
when this light's coming in from 75 degrees, you're going to be able to see how those sparkles are orientated onto that pigment. So if they're
Okay.
slightly different, you'll see the light reflecting off at different angles, and you want them all to be flat, ideally. And 15 degrees is important because that's with your sparkle area. So you'll be able to know if the sparkles are larger or if they're smaller. And really, you're looking at that sparkle area value and how much area of that sample measurement area is actual sparkles. And so you can compare that to your standard and make sure that your formulation and your paint is correct.
Mm-hmm. Mm-hmm. When we spoke yesterday, you talked about light scattering a little bit. Would you mind touching that on that for our audience a bit?
Right. So with the sparkles, if all your sparkles are flat, when you shine a light on it at different angles, you get most of that light reflecting back at the opposite angle.
Yeah.
Whereas if you have sparkles that are these flakes that are laying at different angles and they're all over the place because of the way they were sprayed onto that panel or sample, you're going to get light scattering all over the place. So it's not going to be the same every time. It's going to be randomized light scattering all over the place.
Yeah.
Which is not ideal.
No, definitely not. Okay, another question here. Can you give me an example of what kind of formulation advice the Spectra 2 guide gives, or what process issues it detects?
It's a good question. Let me think about
Let me
that.
read it again. And two, anyone from the field or, from our team on the line, feel free to jump in. But again, can you give me an example of what kind of formulation advice the Spectra 2 guide gives, or what process issues it detects?
So I can, this is Geraldine. Can you hear me?
Hey,
The Cyberchrome on color. We work with that software a lot, and many different industries utilize formulation from Cyberchrome software. Now, metallic software, if you're looking for metallic formulation software, that's a different story. And if anybody's interested in metallic formulation software, they really need to talk to us. We do have a very high-end, commercially available formulation software for metallics, and it's not Cyberchrome. Cyberchrome is designed for non-effect pigment formulations and would most likely work with the BYK-maci. If you're talking about BYK-maci and metallic formulation, that's one thing. And then Spectra 2 Guide and Cyberchrome software is another good one.
Gotcha. Thank you, Geraldine. And that's a good point too. After this presentation, feel free to, hit reply to any of the automated marketing messages you receive. It'll come to my team and we'll route them to the right technical expert. Other questions, keep them coming in. Noah, back to you, some discussion, in talking with customers and clients, what do you see as, and I guess this is to Noah or anyone on our team, what do you guys see as the biggest challenges that customers face out there when they're, working with instrumentation? I know that's a pretty broad question.
Some things I've seen personally is different plants would have issues and they're not getting the same values or results as another plant. And this is because they're not using the same geometries. I've seen it a couple of times where one company is using 45-0 and the other is using D8 specs. And they're saying, why are we getting completely different results? Because they're not getting the correct geometries. They're not using the same exact testing methods.
Hi, Noah. On that same point, can you explain why the 45-0 angle on a BYK-maci will never correlate to the 45-0 Spectra 2 guide?
Yeah, so because of the way the geometry works inside the machine for the Spectra 2 guide, that 45-degree angle is having direct light emitted onto it from all the way around. It's circumferential. So it's in a full circle around that sample. Whereas in the BYK-maci, it's only coming from one angle. It's coming from one side, so it's directional. So it's not going to get you the same exact results. They will be close, but they're not exactly the same as what you'll get with the 45-0.
Yeah. So you really have to make sure, if you're looking at different plants, different shifts, different lines, you're really comparing apples to apples with, the same geometry, on the instruments and the same instruments and running the same firmware and all that stuff. Yeah.
Right.
Hey, John,
Okay.
back to the question about the Spectre 2 guide and process control.
Yes. Hi, Greg.
One of the things that we see a lot of people doing is they're using both the color and the gloss measurement together, and it's in the exact same spot. So any change in their color value on a 45-0, if the gloss is not changing, then they know it's related to pigmentation or something's changing with the actual color of the, whatever they're making. And then if they're using the sphere version, it's kind of just the opposite, where if you have the same color value and you also see your gloss changing, now you know that, okay, overall my pigmentation's staying the same, but my surface is changing. And in a molding process, for example, that might be because of mold wear or any type of thing that can change there.
It's a very good point to bring up, and that's definitely helpful. Another question came in. Can you give me an example of what kind of formulation advice the Spectre 2 guide gives? Or, oh, never mind. We already read that. Sorry. And you answered that. Wrong question here. Okay, here we have, when do you use specular included versus specular excluded in color evaluation in a shop floor QC environment?
So that specular excluded or specular included, you're going to want to use that if you're not looking for visual changes. If you're looking for something that has to do with the actual pigmentation of that color sample, you're going to want to use the excluded. Let me pull that up real quick.
Okay.
Because you're going to want to use the included, because what that is, it's not using any type of structure or gloss value, so it's going to give you exactly what that pigmentation is rather than including that gloss. But if you're trying to include, what the structure is on that sample, then you would use that specular included version, because that's going to give you the what you're going to perceive in the end.
Okay, Larry, did that answer your question, or would you like me to unmute you so you can further elaborate? Give him a second here. Let's see. Hopefully that answered his question. Ping us if not, Larry, and we can unmute you and continue the discussion. Other challenges or issues, Noah, you or anyone else on the team have seen with customers and how we've overcome that. Maybe it's just improper process using the instrumentation or other issues you've seen.
I would just say, just a lack in, how the instrument actually works could play a role in not understanding some results that you get. Because we're dealing with, very accurate instruments, and it gives you all these values, and sometimes it gets a little confusing with all the values, and you're not sure what's actually being read to you.
Gotcha. So just have a clear understanding of what the instrument does and how to actually analyze and report on the data it produces.
Right.
Okay. I'm going to unmute. Oh, go ahead, Ray.
This is Ray. So just a couple of things from what I notice in the industry is people have a hard time sometimes understanding which angle is actually correlating to the angle that they're looking at visually. And I think this is huge.
Hello?
Because it's very important. Go ahead. Did you unmute someone?
Yes, Larry. You're on live with
Yeah, can you hear me?
How about that? Yes, sir. How are you?
Okay. You can hear good.
I feel like a talk show host.
Yeah, I just wanted to ask, as far as the SCI, SCE, we have our gauges set to SCI, and that's how we measure it out in the shop. That's how we do all our color measurement. And just wondering, so occasionally we'll get someone that we get into a debate, the discussion with people about saying whether we should use SCE or SCI. And I was led to believe we should use SCI because we want the specular portion included. So just wanted to get clarification from you on that. And when would it, might be applicable to use SCE?
So, Larry, I think I gave you the wrong information the last time. So you do want to use, if you want color harmony, you want to use specs. And if you want formulation, like Noah was talking about, you want the spin.
Okay, when you say specs and okay, so you're talking specs is
SPE and SPI.
Yeah, specs is excluded, spin is included.
Okay.
Yeah.
Okay.
So say that again, Ray.
Yeah.
So you want to use specular excluded for if you're looking at harmony. Am I saying this right? If I'm saying it wrong, Noah, you can.
Yeah, you're saying it right.
Okay. So the specular excluded includes the gloss, so you want to use that for harmony, and the specular included does not include gloss, so that's more for formulation. So technically, if you use a spin instrument on something and you're looking for color harmony, you're probably going to get lower numbers if the formulations are close, and it's not necessarily going to match what you see visually. Does that make sense or no?
It does, yeah. It's just that we're getting different answers from different folks, so that's I'm trying to.
So that's the real answer. I promise you this time.
No,
Why don't
okay?
We can have one of our regional reps follow up with you directly and go into a longer conversation to help you out if that would work.
Yeah, that'd be great.
Okay,
and probably measure some samples so that you can see the difference, because I think that makes it a lot easier to understand too.
Okay, yeah, because we have to measure color for, the items we're producing, for our end customer. We have to make sure our paint, that we're getting the correct delta E. That's less than 1.0. So the discussion, obviously comes up: is it specs or spin? Is it excluded or included? And it seems like everyone has different opinion. You look online, there's different articles and things. So I want to be able to speak intelligently to it. So
the one thing I can say is that the spin was used a lot when, well, let me say it differently. The spin is used a lot because people think because the number is lower that they're getting a better match to what they see visually with the spin, which is actually the opposite of what's true. The specs matches what you see visually.
Okay.
Well,
yeah, if you have somebody call me, that'd be great.
Absolutely. Yeah, we'll hook you up and give you enough ammunition and background so you can talk to your folks and get this sorted out. So we'll be in touch, Larry. Thank you.
Thank you.
You bet. Okay, another question here. Let's see. Should I dim my QC room light when using the Spectra 2 guide? Does the room light interfere with results?
No, so the room light doesn't interfere with the results because the way the instrument is used, it blocks out all that other light. So when you put it on top of it, just the gravity of holding it on there, it's going to block out the other light. So it's just the measurement area that's in the port that's going to be that measured. So there's no outside lights that's going to affect it.
Okay. Great. Good answer. Let's see, what else? Other questions, folks, or field people. What have you seen out there? What do you want to add to this discussion? How's that for an open-ended question? Anybody else seeing anything out there that can help? Okay, well, actually, another question just came in on this slide. Can you explain what the y-axis represents?
Yeah, so the y-axis represents the values. So you can see on the 45O and the L, for the black glossy sample, you have an L value of 10, so a lightness value of 10. Whereas with the matte surface, you're going to see a lightness value of, let's say, around 22. So the y-axis is just the values for the LAB values.
Okay, great. Great. Can you comment about the LAB delta E tolerances? The 76 versus 94 versus 2000. Yes, definitely another area of debate.
Yeah, so those delta E tolerances with the different equations, if you look into the history, it always gets changed, and there's a debate on which one's the best one to use. But you really have to look into what the calculation is actually doing, or what color you're actually measuring. So with some colors, the calculation is not going to vary that much, but when you're trying to give a value for what we're visually seeing and creating tolerances for that,
Okay.
the newer ones are slightly better because they include different calculations in that main calculation that give you that delta E. But it really depends on what you're trying to do, and some companies I know have made their own tolerances that they ran tests on to see if they match correctly. So it's really a very broad topic that you can go into for a while.
Okay. Yes. Another one here. Is the spin specs advice posted in the chat for gloss applications, or is it all color matching measuring? It is not posted in the chat, but if we could write it up. That's a good idea. We don't have anything specific on spin specs. Any presentations out there, do we? Greg or Ray or anyone?
I think we have one, and we'll look for it for you, and we can post it. I don't have it like immediately, but yes.
Okay. We'll get that to you, Zoe.
And just additional comment on the newer scales, the delta E scales are weighted. So the 94 and 2000 scales are weighted, and like the 76 is not weighted. So they correlate better to visual evaluation, and they size themselves depending upon where you are in color space to correlate to visual perception. But a lot of the makers, so plastic and paint makers and powder coating people, they like the unweighted because they are familiar with how much of a pigment add is going to move them in color space that's not weighted. So it's back to kind of a practical look, but then they can always use any type of scale for their customers who are painting things that for visual evaluation or anything like that.
Okay. Great. Other questions, comments, challenges you're facing at your facility? We have about 10 minutes left, and looking at all the internal Bit Gardener people on the line, I think we have like 2,000 years of color experience.
John, can you hear me?
Yes, I can. Hey, Jim.
John, I have an excellent article or white paper on the difference between the geometries, and I will send that to you for publication.
Wonderful. I'll get that to you, Zoe, and publicize it for the other folks too. Thank you, Jim. Appreciate it.
Of course.
Awesome. Let's see. How many deltas of difference are within specs of any CIE lab value? Good question.
Could you clarify the question a little bit?
We need a repeat, yeah.
Yeah. Jose, do you mind if I unmuted you here? Are you able to jump on and clarify a little more? There should be a microphone icon in your upper right. If you just click that, it'll turn green and you'll be live.
So I can make a comment as she's trying to unmute that.
Sure.
In general, the answer to that question is it depends on what area of color space you're in, because it's going to be different for all different areas of color space. So that's the advantage of the newer weighted values is a 1 value on a green is going to be visually the same as a 1 value for a red versus in LAB, the 1976, those could be 4 or 5 units different to be visually the same.
Okay, so it really depends, where you are in color space and what you're trying to do.
With the older tolerance, for sure. Yep.
Okay. Great, thank you. Let's see, moving on here. How does the color index, whiteness or WI, factor into the evaluation? Any thoughts? You want me to unmute? Larry, you mind chiming in again here? Elaborating on your question a little bit? You should be able to unmute yourself again. Give him a minute here, but how does the color index factor into the evaluation? Maybe Larry's head spinning. You there, Larry? Okay. Well, chime. Yes, you should. Let's see. I think you can unmute yourself from your end, sir. You're unlocked. There should be a icon in the upper right hand corner.
Yeah,
there
can you
you
hear
are.
me? Okay.
Yes, now I can.
Yeah, it's another setting in our color gun, and just wanted to know how much it factors in.
Okay. Yeah, white. The
You
color index for white.
Yes, you're choosing. You're choosing your delta E, your LAB or LCH, your delta E equation, your observer, illuminant, and it's just another option you have. So I was curious how it factors in.
I would say the whiteness index is mostly how we talked about the jetness indices for the deep black colors. It's almost the same thing. It's like its own calculation for determining how white that sample may be. It's like its own special indices, like the just like how the jetness indices are with the newer model.
Does that help?
A little bit. I guess trying to figure out how to set it. There's a number of different settings for it. Different selections. So,
is it a requirement for your customer, or is it just something that you're
interested? Know how much it it would change, or how important it is. I heard it was important with when they, I guess, checking color of cloth, of linen.
Yes, that is true. It's a reference to how white something is compared to like a perfect white diffuser. And so it's popular in textile industry for substrates. And sometimes people would use it for maybe TiO2 comparisons, or looking for an offset, or how much of a certain additive I can add to my TiO2 or my white paint to get the same amount of whiteness or lightness, if you will, out of that particular paint or color. And so
Okay.
it would be influenced by A/B changes for sure, but if it's really heavily moving and you're comparing like different gray levels, then you can go to a gray scale, which is like comparing color difference compared to a neutral color. So sometimes people do that. Again, that's a textile thing that's very popular in textiles.
Okay. So if we're doing just non-textile spray liquid painted items, then we could leave it at just a factory setting, and that should be acceptable.
Yeah, it should give you a pretty repeatable value if you're doing whites.
Okay.
It's not going to be of much value if you're comparing anything other than white colors.
Okay. Yeah, we're doing we're doing all different colors in the spectrum: red, yellow, green, blue, blacks, white. So
I don't think that would add a lot of value. Yeah.
Okay. Yeah, just if it's textile industry, then it would be important.
So specifically for the substrates before they're dyed.
Oh, okay.
Okay.
Thank you.
You bet. And I did send you that information, Larry, and copied in Jonathan Bain, your regional sales rep. So you should be hearing from him shortly. Okay. What else we got? Oh, you're welcome. Just a couple minutes left. This was a really good discussion. A lot of good points here. Noah, any final words from you?
No, nothing else from me.
Okay. You did a great job covering everything, so we appreciate it. Anyone else from the team? Greg, Ray, Jim, Jonathan, John, Geraldine, Mary, anybody else have any final points they'd like to highlight or hit on before we go? Crickets. Okay, that's good. Going, gone. You can see Noah's email there. Feel free to take a screenshot of this. Jot it down. If you have any questions, you can email him directly. Like I said, you can hit reply to any of the marketing messages you received. It'll come to my team, and we'll route it to Noah or the appropriate business line or inside or regional sales manager to help you out there. Thank you very much for joining us today. Thank you, Noah, and the rest of the team here. You should be getting the recording link shortly. Feel free to take a look at that, share it with colleagues, whatever you like. And from there, have a wonderful day. And we look forward to seeing you on future Big Instruments web seminars. So thank you, everyone.
Thank you, guys.